Hello, and welcome back to Business Statistics. So today we're looking at time series analysis, which is chapter 14, almost the end of this book. So this chapter starts by looking at index numbers, which have a base period of 100. So to form a price index, we express it as a percentage where we multiply 100 times P sub 1, which is your second period, divided by P sub 0, which is going to be your base period. I'm going to show you a table next that talks about airline prices to give you an idea of how this works. So in this example, the table shows your airplane ticket price example where your base year is 100 in 2005. So as you can see here, 2005 is going to be your base period 100. And if we plug in the formula 100 times P sub 1 divided by P sub 0, for example, for say 2001, the way we would come up with a result is we would multiply 100 times this price for 2001 divided by the base price 320. In this case, for 2001, it would be 100 times 288 divided by 320, which is going to be equals to 90. So that is how you would calculate a time series analysis example for here airplane tickets. Now, an aggregate price index can be weighted or unweighted. Looking at an unweighted aggregate price index first, we would use a similar formula where we would multiply 100 by the sum of prices P sub T for time divided by P sub 0 for time period. Here's an example where the models for 2007 for automobiles, the lease payment is 260, fuel 45, repair 40, for a total of 345. Now the way we would calculate for the model for 2010, we would take the 100 times the total for 2010, which would be 410 here. And similarly, we would divide it by the P sub 0 index of 2007, which we determined that was our base year. So when we do that, we would write the formula 100 times 410, which is the total for 2010, divided by 345, which is going to be our total for 2007. That would equal to 118, and that would be our value. Now, if we take a look at the weighted indexes, we could use Lesperer's price index using a similar formula where we multiply 100 by the sum of quantity of items in time period T divided by the quantity of items in period 0. Now the chapter then looks at runs test to determine if there's a pattern in a time series and whether it's random. R is the number of runs, and the null hypothesis is that time series is random. The significance level is doubled if it's less than 0.5. Now there's a useful YouTube video on this that you might want to take a look at when doing homework assignments called How to Do a Runs Test in MS Excel 2007. Again, doing it in Excel is going to be much easier than trying to calculate it manually. The chapter then talks about the time series components. First, we have the trend component, which is characterized by the long run upward or downward trend. This is something we look often at in investments, where if we plug in stocks over the longer term, we get a total different picture than if we look at just short-term results. This could definitely affect your investments depending on what your time frame is. Trend charts also show you a linear trend versus a nonlinear trend. And irregular components that affect long-term trends are random nature accidents. COVID, for example, is considered one of these events that will throw your graph off. Time series analysis is used mostly for forecasting, where the formula for time series equals the trend plus the seasonality plus the cyclical value plus the random values. A moving average is a designated number of consecutive values in a time series. And there's also a helpful YouTube on this one called How to Calculate a Moving Average by Stephanie Glenn that you might want to check out when doing homework assignments on moving trends. The book then talks about a centered moving average. This is often used for quarterly averages. To calculate a ratio to moving averages, you divide an actual sales by the average for that period. Calculating a seasonal index is something very commonly used to forecast sales in companies that sell products or services. Now, there is a useful YouTube that you might want to check out on this called Forecasting Methods Made Simple, Seasonal Indices by Piyush Shah. That might be useful when doing this type of homework assignments. And the last thing we're going to cover in this chapter is exponential smoothing, which we weigh decline exponentially. The smoothing coefficient we use is alpha, which is close to 0. And there's also a useful YouTube for this one called How to Perform Exponential Smoothing in Excel 2013 by Stephanie Glenn. Hope this was helpful to you, and we'll see you next time.